before beginning this lecture, I want to discuss the previous lecture. In previous lecture, we were discussing about the type of forces in a fluid flow, and then we discussed about dimensionless numbers. Right? So again, I want to recapitulate the whole topic here because of some you can say a connection problem. It got disconnected. So let us just quickly recap these topics: the type of forces and dimensionless number. Okay, so the type of forces we are supposed to discuss in a fluid flow are these forces. Namely, these are inertia force, viscous force, gravity force, pressure force, surface tension force, and elastic force. Right. So inertia force. See, all of these forces are very basic force which we study, which we usually study in physics from our schooling time. So in physics, we study these forces, and if I want to just to tell you the basics about these forces, like inertia force is basically due to the movement, the force generated due to the movement of a particular object. So that is called as inertia force. Mathematically, it is derived from the equation of motion. It could be called as the product of mass and acceleration of a flowing fluid. Right? So that is called as inertia force. Second is called viscous force. Now, viscous force, basically viscosity, I have told you, viscosity is the restriction or the resistance in the fluid flow. So that resistance occurred because of the shear stress between two layers. Okay, one layer must be applying some shear stress on the second layer, right? So due to which some viscosity occurs, right? So the force generated due to shear stress, those forces are called as viscous force, right? So that we had discussed. And then the third one is a gravity force. You know, gravity force is due to the weight of the particular object. Now, if somebody is weighing if somebody is weighing 50 kilograms, so 50 kilogram is the gravity force of a particular person. 50 kilogram, we usually term it as 50 kilogram, but if you measure weight, it is 50 newtons or something like that. Right? So weight is basically the gravity force of a particular object or of a particular, in terms of fluid flow, it will be the weight of the fluid element or the flowing fluid. So that will be the gravity force. Next will be a pressure force. Now, similar to the viscous force, pressure force are due to normal stress. Viscous force are due to shear stress. Pressure force are due to normal stress on a particular fluid element. Fine. So if the normal stress is acting, so force generated due to the normal stress or the pressure intensity into cross-sectional area. So that is called as pressure force. The second last is surface tension we had discussed. So surface tension, again, we had discussed the surface tension is a property of a fluid in which the free surface of the fluid, you can say, is under a constant elastic forces. Right? So those elastic forces on the free surface is called as surface tension force. Okay. And last is a elastic force. Now, what do you mean by elastic force? See, you are familiar with this term elasticity. Elasticity is what? When you apply a force on a particular object, and that on removal of the force, that object will try to regain its shape. That is called as elasticity. Fine. Ability of an object to regain the shape after removal of the force. That is elasticity. Fine. So, what is elastic force? Like in case of a spring, if I give you an example, like in case of a spring, if you try to, you can say, stretch a spring. Fine. So spring will try to develop some restoring force, so that spring will try to regain its original shape. Fine. So that restoring force is called as elastic force in terms of spring. Similarly, in case of fluids also, what will happen? Like let's say if you take an take example of water. Now, if you try to compress water, if you try to you can say apply pressure on the water, what will happen? Since water is incompressible, water will try to apply an against opposite force on the applied compression. Fine. So that force will be called as elastic force. Right? So these are the different types of forces in a fluid flow. By definition, you should know these forces. Now, based on these forces, we can define certain dimensionless numbers. So those dimensionless numbers we are supposed to you can say know. Namely, these are again Reynolds number, Froude number, Euler number, Weber's number, or Mach number. Right. So these are some dimensionless number that you should know. Again, one by one, I'll tell you what are the definition of these numbers and what are the, you can say, physical importance of these numbers. Like Reynolds number, again, if you go by the definition of Reynolds number is the ratio of inertia force and the viscous force, right? So basically, Reynolds number is the ratio of inertia and viscous force. You can see it over here also. It is the ratio of inertia force and viscous force, that is called as Reynolds number. Or mathematically, you can write it as like this: inertia force by viscous force is Reynolds number. And you know, inertia force is due to the, you can say, movement of a particular object. Fine. So movement can be defined as mass into acceleration. Fine. So mass into acceleration, or you can mathematically, if you rewrite the whole term, if you go into the derivation, you can write the inertia force as rho AV square. That is called as inertia force. Right? Mass into acceleration is further converted, and with mathematical manipulation or simplifications, you can find inertia force is rho AV square. Similarly, viscous force, from Newton's law of viscosity, I can say viscous force will be stress into area. stress into area, fine. So from here you can define viscous force as this expression, fine. So you can, if you take the ratio of these two forces, you will get Reynolds number. Okay, you need to remember the formula of Reynolds number, because in the coming topics also we need to find Reynolds number. So it is better if you remember the formula of Reynolds numbers. So basically Reynolds number is rho VL by mu, where rho is the density of the fluid, V is the velocity of the flow, L is the length, okay, characteristic length of the flow, and you can say mu is the dynamic viscosity, right? So that is called as Reynolds number. Now, suppose this formula of Reynolds number is applicable in an open channel flow. Whenever the flow is taking place on an open channel like flow on a river. Okay, flow of a river is an open channel flow. Right? So in such cases, flow over a flat plate. Right? So in such cases, such type of flows are called as open channel flow. And in open channel flows, you can apply this formula of Reynolds number. But when the flow is inside certain something, fine. So when the flow is, you can say inside a pipe. Okay. So in case of a pipe flow, Reynolds number, the formula is little different. So instead, in a pipe flow, instead of L, we are taking the diameter of the pipe. Okay. So rho VD by mu. In this case, the formula is rho VD by mu. Okay. So that you need to remember while calculating Reynolds number for a pipe flow. Now, significance of Reynolds number, we know that Reynolds number is used to classify or distinguish a flow into laminar flow or turbulent flow. Based on the number, based on the value of Reynolds number, we can you can say define a flow to be laminar or a flow to be turbulent. Fine. So that is the, we can say, significance of Reynolds number. Second number which we had studied was a Froude's number. So Froude's number, again, by the definition, if I go by the definition, it is the ratio, it is the square root, it is the square root of the ratio, of inertia force and gravity force. Fine. So mathematically, Froude number is ratio, square root of the ratios of inertia and gravity force. So that is called as Froude number. Fine. So if you know the definition, again, we can convert inertia force as rho v square, rho av square, and gravity force as the weight. Okay, rho into you can say g, rho into v into g. Okay, so rho into v into g is the gravity force, and rho av square is the inertia force. So if you simplify these things, you will get this is the Froude number. Right? So mathematically, this is the expression of Froude number. Now, what is the importance of Froude number? In the last class also, I have told you that Froude number, if the Froude number is greater than 1, if the Froude number is greater than 1, that what does it means? Suppose this Froude number application is used in a type of flow where an object is floating on a fluid. Suppose the object is floating on a fluid, like in like a case of ship. Fine. So ship usually floats on a fluid. Fine. So when the ship is driven, when the ship is you can say driven, when the ship is sailing over the fluid. Fine. So how much resistance is offered? How much resistance is offered in the movement of the ship? That depends upon the value of the Froude number. Fine. If the Froude number value is greater than 1, okay, if the Froude number value is greater than 1, that means the resistance is less. And if the Froude number is less than 1, if the Froude number is less than 1, that means resistance is more. Fine. That means the ship is experiencing more resistance while sailing through the fluid. Fine. So basically, whenever the ship is designed or the motion of the ship is, you can say, calculated, we usually take Froude number, critical value of Froude number equal to 1. Right? So that is the, you can say, significance of Froude number. Whenever we are talking about movement of a floating body on a fluid, we usually take Froude number in our account. Okay, so that is the significance of Froude number. Both the things both the things like definition and the significance should be known to you, because anything can be asked in the objective question. What is the significance of Froude number? What is the, you can say, definition of Froude number? So both you know. Okay. So if it is clear, Froude's number, let us go to the next. That is Euler number or Euler number. So Euler number is basically, I can say, it's a, you can say, it's a ratio of pressure by inertia force. Okay, it's a ratio of pressure force by inertia force. Right. So pressure force, you can note, pressure force is pressure into area. Pressure force is pressure into area, and inertia force is mass into acceleration. Again, similar way. Fine. So it is the ratio of pressure by area, pressure by the inertial forces. That is called as Euler number. Now, this is the definition: Euler number, pressure force by inertial force. Okay, this is the definition. Now, what is the use of Euler number? Use of Euler number is basically, let's say, when we talk about pumping system. Okay, when you're supposed to you can say transfer some liquid, let's say some liquid in section 1 to section 2. If you want to transfer the liquid from section 1 to section 2, what you will do, you will pump this liquid from this section to this section. Fine. So while pumping, there are pumping losses which occurs. Fine. There are pumping losses which occurs. There are frictional losses which occurs. Fine. Okay. Now this Euler number will tell you that that what is the extent of pumping losses or pressure loss happens due to this fluid flow. When the fluid is flowing, fine, how much is the pressure loss or the pumping loss has occurred. So that is represented by Euler number, fine. So Euler number greater than 1, that means lesser loss, and Euler number less than 1, that means this is called as greater loss. Okay. So in the same way, you can understand Euler number values. Next is a,
Sir,
yes.
sir, excuse me, sir. Sir, actually, sir, there was no light from yesterday, sir. That's why, sir, I joined, sir, just now, sir.
Okay, Shivam, no problem, no problem. I'll mark you present.
Okay.
All right. Next number we supposed to discuss is a Weber number. Now, what is Weber number? Again, we'll go by the definition first. So, definition of Weber number is square root of inertia force to the surface tension force. Okay. Now, this is the square root of inertia force to the surface tension force. That is called as Weber number. Okay. So, this is the definition of Weber number. Mathematical definition of Weber number: the square root of inertia by surface tension force. Now, what could be the significance or what could be the use of Weber number? So Weber number is used in a case like suppose we are talking about a fluid flowing through the pipe. Okay, like in case of a turbine. Okay, in case of a turbine, when the fluid is flowing. Okay, now when the fluid is flowing, it must be going some under. It must be going. See, the velocity of the inertia force is just because of the velocity of the flow. Okay, mass into acceleration. Now when the fluid is flowing. Okay, and what will happen? What will happen if the again, sorry. Okay. Now Weber number is what is the significance of Weber number? I'm discussing. If the Weber number is greater than 1, okay. If the Weber number is high for a fluid flow, if the Weber number is high for a fluid flow, there is a possibility, there is a probability that in the fluid there may be a bubble formation. Okay. So when the fluid is flowing and if the Weber number of the flow is very high, so there is a possibility that bubbles may form in the fluid flow because the fluid is flowing with higher velocity. Either the fluid is flowing with higher velocity, or if the surface tension of the flow is low. Now, if the surface tension of the flow is low, what will happen? It may form bubbles. Right? Okay, it may form bubbles. Why I'm saying this? Suppose when you boil when you boil water, what happens? Due to boiling of water, bubble forms. And you know, while boiling a water, surface tension of the water is decreased, right? So if the surface tension is reduced, the bubble will form, or if the inertia force is increased, that means velocity is increased, the bubble will form. So if the Weber number is high, so there may be a chance of formation of bubbles, and these bubbles may cause pitting, may cause cavitation, may cause flow losses, fine. So we usually try to avoid the Weber number to be very high, right? So while a fluid flow, if the Weber number is high, that means there is a tendency or there is a probability of formation of the bubbles, right? So that is the significance of Weber number. So these are some dimensionless number. Last number is called as a Mach number. Okay, so let's try to discuss Mach number. See, this number we usually have heard this number also, and the definition which you may be knowing for Mach number is that it is the velocity of the object to the velocity of the sound, right? You usually know the definition of Mach number as velocity of the object, or I can say in our case of fluid, it is the velocity of fluid element to the velocity of the sound in the fluid. Fine, so that is called as Mach number. But in terms of forces, Mach number is the square root of inertia by elastic forces. Mach number is the, you can say, ratio of square root of inertia force by elastic forces, right? So that is Mach number. Okay. Now, what is the significance of Mach number? If the Mach number is greater than 1, what will happen? That flow is called as supersonic flow. Okay. If the Mach number is greater than 1, that flow is called as supersonic flow. So in that case, what will happen? There is a compressibility. The density of the fluid flow may change. Okay. Density may vary. If the Mach number is very high, so density may vary, and if the density is varying, that means the fluid can undergo compression or expansion. Okay, so such type of flow is called as compressible flows. Okay, so compressible flows, and if the Mach number is less than 1, so we assume that the density remains almost constant. So such type of flows are called as incompressible flow. So based on Mach number, you can classify a flow to be compressible flow or incompressible flow. That is the significance